Good morning, students. Today I have explained subject Computer Studies, Standard 10th, Chapter number 11, Data Types, Operators, and Expression in C language, Part 1. First, what is a data type? The type of a value that can be assigned to an identifier is known as its a data type. Example, if an identifier date has been assigned a value, then data type of date is integer and identifier is associated with its data type by using the syntax. Data type identifier 1 big bracket comma identifier 2 comma identifier 3 dash 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 and identifier and each data type in C is allocated a fixed memory space. It is denoted by bytes. 1 byte equal to 8 bits. C language support basic data type called integer, decimal and character. These data types are represented using keywords int, float and chr respectively. An identifier is associated with its data type using the syntax data type identifier number 1 big bracket comma identifier 2 comma identifier 3 dash 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 and identifier and the contents written in square brackets for the given syntax are optional. Any variable in C need to be declared before using it. The statement that declares a variable in C is called a declaration statement. Various type of data type. So first is a integer. Integer that means int. And integer means the whole number. It is a positive such as 1200 12 lakh 900.300. Sorry, such as 12,900 comma 300 or a negative whole number such as minus 99 minus 10 minus 12 to declare an integer variable. We use the syntax int identifier 1 brackets comma identifier 2 identifier 3 dot 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 and then identifier n. So example is the first int roll number, second int date comma month comma years. So that is a integer data type. In ANSI integer data type use 4 bytes or 32 bits memory space. It has a range of -2147483648 to +214748364111. The variable defined with int are signed variables, i.e. they are capable of storing both positive and negative values. For signed integer, the value of range is calculated as -2 raised to n minus 1 plus 2 plus 2 brackets n minus 1 years n refers to number of bits required. So next is a unsigned integer. So inside int, the variable declared in the above example, date, month, year, roll number, and etc. are signed. It in many situations when we are aware that we will not require a negative value at all, we can define the variable using a keyword unsigned. So example unsigned int roll number, unsigned int date, comma month, comma year, and then next is a long int populations. So long integer, that means a long int, it is possible to increase the range of integer numbers by using a prefix long with the integer data type. So example is a long int populations. Here long int is a data type and population is a variable declared. Adding long as a prefix to int allocate 8 bytes or a 64 bits memory space to the variables. So figure 11.1 shows the code listing for a program illustrator integer data type. So before the example, so that is a table integer data type. First is data type, second is the range, and third is a byte required, and then example int minus 2147483648 plus 2147483647, and byte required is a 4. Example int balance underscore amount. Next is the unsigned integer 02 4294967295. That means only for positive numbers. So bytes required is the 4, and example is unsigned int counters. So that is a example. Example number 1, program to illustrate use of integer data type. Hash sign includes treated as int main, int marks equals to -10, unsigned int date equals to 30, long int population equals to 4294967295, and then printf mark equals to %d, that means integer, comma mark. Second printf backslash and date equals to %u, that means unsigned integer, comma date. Next is a printf backslash and population equals to %ld, long int, long digit, that means ld, backslash and then populations, and last is a return 0, end of the curly brackets main. So that is a program for integer data type, and that is a result, it means output. First is a compile and second is a output. So marks equals to -10, date equals to 30, population equals to 4294967295. Next is a real data type. So real, the int data type is used to store whole number. To store a real number, C language support floating point data type. Float, the variable for float values are identified by keyword float. Example is a float amount underscore to underscore pay. Here float is a data type, and amount underscore to pay is a real variable declared by the statement. The float data type use 4 bytes or a 32 bits memory space. It has a range of plus slash -3.4e -38 to plus slash -3.4e plus 38. Float value are precise to 6 and at a time 7 decimal digits. And next is a double precision. So double precision keyword, double is used when we need high precisions, i.e. precisions more than 6 decimal digits. So example is a double balance underscore amount. Here double is a data type and balance amount is a real number declared by the statement, which store the real value having higher range and precisions. The double data type uses 8 bytes or a 64 bits memory space. It has a range of a plus slash minus 1.7 e minus 308 to plus slash minus 1.7 e plus 308. Double value are precision to 16 and at a time 70 decimal digits. And third is a long double precisions. So long double precisions, adding a long as a prefix to double increase the range of a double variable. Example long double credit. So that is a data type, range, significant digit, bytes required, and then example. First is a float. Uh, Significant digit is 6 and bytes required is a 4, and example is a float price. Next is a double. So that is a range plus and minus. Significant digit is a 16 and bytes equals 8. Example double total underscore price. Next is a long double plus and minus value, and significant digit is a 16 and byte required equals to 16, and example long double credit. So that is a float data type. Next is a the memory representations of float is display as follow. So that is a number 0 to 31, 0 to 31. So 0 to 22 is a mantissa, 23 to 30 is a exponent, and last 31 is a sign. So that is a memory representation of a float. Next is a example. So program to illustrate use of a real data type, use of a float data type program. Lesson includes stdio.h, int, main, starting curly brackets, and that is a slash star and star slash is a comment line. Float first equals to 987654321 and second is a double second, third is a long double, and third. So first data type is a float, second data type is a double and third is a long double. Printf first equals to percentage f and comma first. Printf backslash and second equals to percentage lf small lf and comma second. Third, printf backslash and third equals to percentage capital L and small f backslash and then third. Return 0 end of the curly brackets main. So that is a output. So first value, second value, and third value. So first value, the first three statements after the opening curly brackets declare the three variables. Float first, double second, and long double is a third. Each of this variable is assigned a float value. Second, the statement printf first percentage f prints the value of variable first along with the message. Looking at the output properly, we can see only 7 digits of a variable first are matching the actual entry, and this is because float is precise to 6 and at times 7 decimal digits. Third, the statement printf backslash n and second equals to percentage lf, that is a second printf the value of variable second along with the message. The output represent first 17 digits of the actual value. This is because double float are precise to 16 and at a time 17 decimal digit. Number 4, the statement printf third equals to percentage capital L and F backslash n third, the prints the value of variable third along with the message. Here the same expressions apply as given in number 3. So that is a output of example. Next is a character data type. So character data type, that is a CHAR. The CHR data type is used to store a single character, that means alphabet. Example, gender, uh, female, that means F, and male, that means M. Please pay yes or no, that is etc. etc. Keyword character CHR is used to declare a character variable. Example, CHR gender. Here CHR is a data type and gender is a character variable declared by the statements. So that is a data type range bytes, and then example CHR minus 128 to plus 127 and bytes required 1. Example CHR gender unsigned character 0 to 255, bytes required 01, and example unsigned CHR choice, that is a character data type. And that is an example of a character data type. Has sign include st.h int main chr gender equals to small m, chr answer equals to capital M, chr number equals to 2, chr special character equals to space. Printf, the character stored in gender is percentage %c and its ASCII value is %d, gender and gender. Printf uh, second, the character stored in answer is %c and its ASCII value is %d, answer. Third, printf, the character stored in number is %c and its ASCII value is %d, number and number. Printf, the character stored in special character is %c and its ASCII value is %d, \n, special character, return 0. End of the program. So save your file with accession.c, and that is a output. The character stored in gender is small m, is ASCII value is 107, second capital M, ASCII value is 77, stored in number is 2, the ASCII value is 50, the special character is space and ASCII value is 32. So that is a output of next is a empty data type set. So empty data type set, that means C provides a special data type which has no value. Hence we denote it to be empty. This data type is identified by keyword void. C programs consist of a function. Functions in C may return a value. If we don't want a function to return a value, then we can prefix it with void. So example, all C programs contains return 0 as last statement. These statements provide exit from main. If we want to write this statement, then we will get a warning message function should return a value. To avoid getting such a message, we can prefix main with the void. Next is a assigning value of variables. So user defined data types. Next user defined data types. C is a flexible language. It allows user to create a new entity from existing one. One can create a new data type by making use of a existing data type. There are two types of user defined data type in C. First is a type definition, that means a type DEF, and second is a enum. So I extend first type definitions. Type DEF. The type definitions variable can be declared using keyword type DEF. The syntax for using type definition is as follow: type DEF data type variable. Here type def is a keyword used to create user defined data type. Data type refers to an existing data type such as int, float, chr, etc. And variable refers to new name, alias name, nickname given to the existing data type. So that is a example. Type def chr alpha, type def double twice. Next is a enumerate data type, that means a enum data type. So keyword enum is used to create a enumerate data type. The syntax for using enum is as follow: enum identifier, curly brackets, value 1 comma value 2 comma value 3 and dot 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 and then value n. Here enum is a keyword used to create a user defined data type. Identifier is the name that can be used to define a new variable, and value 1 to value n refers to name of a numeric constant 0, 1, 2 and then etc. The variable defined using enum can be assigned any numeric value or a value given in curly brackets. So that is a example: enum money, curly brackets, rupees comma dollar comma pound comma yen and then semicolon. Enum money, that is a currency, and currency equals to dollars. So that is a invalid data type. Next is a derived data type. So C provides a derived data type for grouping of variable. Array structures, union and pointers, etc. are example of derived data type. Amongst all these, we will learn about an array. So array data structure consists of a group of variables having some property. The syntax for defining an array is as follow: data type variable and then big bracket size and semicolon. Here data type may be any basic data type, user defined data type of derived data type. Variable is name of an array and size refers to number of elements in the array. So the example of a chr, and the variable name is a subject name and then brackets 10, that means a size. So next is a operators and expressions. An operators is a symbol that identify the operations that can be performed on data. The data can be variable or constant. The data on which the operations is performed using operator is known as a operands. This means that operator process the operands. So that is a example: 5 plus 6 minus 3. Here 5 plus 6 minus 3 is an expression. plus and minus are operators, and 5, 6, and 3 are operands. So C language provides 8 types of operators. First is a arithmetic operator, second is assignment operator, third is a relational operator, fourth is a increment and decrement operator, fifth is a conditional operator, sixth is a logical operator, seventh is a bitwise operator, eight is a special operator. So first, arithmetic operators. So following table represent various operators and its use. So plus sign operators, addition of two operands or a unary, plus minus subtraction of a two operands or a unary, minus star, that is a multiplication of two operands, slash, that means the division of two operands and resulting question, and percentage, that means division of two operands resulting in reminders. So first, operators is known as a modulo or modules operators. It is used to get remainder when performing division of two integer operands. Second, percentage operator cannot be used with float operands. And third, C language does not provide any operators for power. So that is the example. Total underscore cost equals to quantity into cost item. So this is a C statement from a C expressions. Next is a integer arithmetic. When the operands used in expressions are positive or negative whole number, it is considered as integer arithmetic. The expression here is called integer expression. The result of integer arithmetic is always integers. So that is a example program to illustrate use of integer arithmetic. Has sign includes TYPES int main, type def int whole number, total cost equals to 650, quantity equals to 24, and comma cost item. So cost item equals to total cost divided quantity, printf, cost of one item is percentage d, backslash and then cost item return 0. So that is a output. Cost of one item is 27. So that is a output. And next is a real arithmetic. So real arithmetic, in real arithmetic, all operands used in an expressions are float, and the expression is called a real expression. The result of real arithmetic is always represented in decimal values. All the arithmetic operators except percentage, that means a modulo operator, can be used in real arithmetics. So that is a example of program to illustrate the use of float arithmetic. Has and includes TYPES int main, type def float, decimal, total cost equals to 650, quantity equals to 24, and cost item equals to total cost divided quantity, printf, cost of one item is percentage of backslash and cost item and return 0. So the output is a real number, that means a float. That means the cost of one item is 27.083334. So that is a use of a float arithmetic. Next, mixed mode arithmetic. Mixed mode arithmetic, that means both the type of operands, integer as well as a float operands, can be used in mixed mode arithmetic. The output will depend upon the data type of variable to which value is assigned. Next is a assignment operator. So assignment operator, in the above examples, we have used the statement such as a cost item equals to total cost divided quantity. Here the symbol equals to is known as a assignment operator. It is used to assign a constant value or a result of an expression to a variable. C also provides shorthand operators. It is obtained by prefixing arithmetic operators such as plus, minus, asterisk, and that means multiply and then divided to equal to. The syntax for shorthand operator is as follow: variable AOP equals to constant value. Here variable refers to variable name, AOP refers to an arithmetic operators, while AOP equals to is known as a shorthand operators. So example is a first minus equals to 1. So this statement is equivalent to first equals to first minus 1. Second, first plus equals to 3. This statement is equivalent to first equals to first plus 3. Third, first into equals to bracket second plus third. So this statement is equivalent to first equals to first into second plus third. So today class is over. Next time I will explain the remaining part in the next sessions. Thank you.